Alrighty, everybody, I just got it okay to start the last planetarium show of the day. So I want to be putting away our space trivia questions and that important message up on the screen because now we're going to be heading into the unknown. Ooh. And good afternoon, everyone. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm a real person and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. Everything that you see in purple is going to be the entire screen. Thanks to the help of 6 different projectors hidden throughout our planetarium dome. I just want to let you know that I'm here. I'm an actual person. And folks, I'm very excited to have y'all here because you are about to see a very fun show. My favorite show, personally. This one's called Tour of the Universe. And with Tour of the Universe, this show is completely live. So you're going to hear my voice for the next 30 minutes. And what this show entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. And before we get started with our tour of the universe, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. First off, folks, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater as clean as possible for all the guests and also easier for everyone. Also, if you happen to have any cell phones or smartwatches, anything that produces really bright white light, now's the time to turn them off, put them away for the next 30 minutes, as these can be quite distracting, not only for you, but for the folks sitting behind you. Really takes away from the planetarium show experience. And folks, if you need to exit early during our show, you're more than welcome to do so. All we ask is that you exit towards the top of the planetarium. That's where you're going to find the exits before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. Although if you have trouble climbing the stairs, don't worry, we understand. The staircase is quite steep, so if they pose a problem for you, all you gotta do is stay seated. Once the show's over, we'll have someone escort you to a lower exit once the show wraps up. And last but not least, folks, this show is quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you gotta do is close your eyes, take a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth, not right on it, but just above it. Here at the International Space Station, we're hovering just above Budapest in Hungary, and then we also got Italy right over here. But again, we're starting off at the spacecraft right in front of us called the International Space Station, or the ISS for short. Now, a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in articles and news, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they conduct all different types of science experiments up here that we couldn't really do closer to the Earth, which has a lot of gravity. Some experiments that they'll conduct up here are things like, ooh, what happens when you try to grow plants in space? Which way do the roots grow with less gravity? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of body muscle just because you don't have as much gravity working down on your muscles. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry, you can also use the entire California Academy of Sciences, the museum we're sitting in right now. And also what's really impressive is that this thing is going really, really fast. The International Space Station's orbiting the Earth at about 1,700 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this looks really far away from our planet, but it's only 225 miles above our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to be honest, folks, this is as far as we put humans into space nowadays, because traveling into space is quite costly. You got to build yourself a rocket ship or buy yourself one, and then when you get your hands on that, you have to account for a lot of rocket fuel. You're going to need so much rocket fuel, you got to be able to leave the Earth's gravity. And once you acquire all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe, so now we're going to see it start to slowly disappear. We're going to lose it to all the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly disappears. So let's continue zooming out. Alrighty, everybody, we now zoom so far out, we're now able to see our entire Earth in all of its glory. And I want to let you know that the space program that we're using in here in the planetarium is something that you can go home and download if you want to check it out and fly through space just like how I am. The space program that I'm using in here is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you can download this and have a lot of fun. But just a heads up, OpenSpace is in its beta phase, which means it's not completely finished. We may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also this uses a whole lot of processing power. So if you have an older computer, it may overwhelm that computer, so just a heads up. And also, folks, if you're a person that doesn't want to download anything, you just want to click a link and fly through space, we also have another great alternative called NASA's Eyes. So just like the human eyeball, go to your favorite search engine, type in NASA's Eyes. You don't have to download anything, and it's a whole lot of fun. So we got OpenSpace Project and NASA's Eyes. I could see some data missing towards the top. Let's ignore that. But now that we got a good sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. Alrighty, everybody. Again, we're now approaching the moon, and we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun as well. They got to play some golf up here as well. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the coming years, thanks to NASA's new space mission in the works called Artemis. Pretty much, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we want to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone to figure out all the logistics of how we'll be doing that. And what's really cool is that NASA just launched its rocket, Artemis 1, just this morning, so late at night, depending on where you are in the United States, or early in the morning. They just sent the test rocket, and it's going to be reaching the moon in about 4 days. So that's really cool news. And what's really exciting is that once they send actual astronauts to the moon, they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also planning on setting up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years, and we're able to conduct a lot more science in a much more compactable size. And one place that we definitely want to set up a lunar base on the moon is the South Pole. The reason why is because we found a whole lot of ice there, and ice is going to be very helpful because we can melt it, pass electricity through it, and separate the oxygen and the hydrogen, and both of those are very valuable, especially when you're out here in space. So again, look out for any news about Artemis in the coming days. Should be really exciting stuff. And folks, when we look up at the moon here on Earth, sometimes the moon feels really close to us, feels like you can reach out your arms and touch it, but it's incredibly far away. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it, and if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers instead like to use something a little more convenient. It's called the speed of light. And light travels at the mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to be stepping into a much larger, greater realm of our solar system because now we're going to watch the moon and the Earth as they start to slowly disappear. In fact, before we start to lose track of them, I want to add some nice planet trails so we can keep track of everything because, again, space is so big, you can easily lose stuff out here. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models showing us the most accurate images and information available to us. Now, the nearest star to us, the sun, should be coming into view in just a moment. Alrighty, so here comes the sun. Do 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 do. And folks, the sun is also incredibly far away from the Earth. The sun's about 93 million miles away from the Earth. 93 million miles. Whew, that's a good distance away. But in terms of speed of light, that's not too far away. So again, we're the third rock from the sun. 1, 2, 3. That's us over there. 93 million miles between us. In terms of speed of light, it only takes sunlight about 8.5 minutes at the speed of light to cross that distance. Only 8.5 minutes. Not too bad. But now that we have a nice bird's eye view of our solar system, let's get a quick refresher of what's here because we got some good stuff. Right in the middle, we have our star, the sun, the biggest thing by far. The closest planet to the sun, we've got Mercury. Then we have Venus, and of course us, Earth. And after that, we got Mars, the red planet. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belts. And this is what it would look like if I highlight all those asteroids. There is a lot of them. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all, Saturn, famous for its rings. And then now we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, just right down below. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. So the Kuiper Belt is like a second asteroid belt past the orbit of Neptune. And mostly what you're going to find out here are icy asteroids and short period comets. Comets that don't go too far away from the sun. Nice little orbit like so. And what's really amazing is that We didn't really know about the Kuiper Belt until about 2006, and the reason why is because our telescopes were able have improved and gotten better, and we're able to see much smaller objects much further away. And that's the really cool thing about science, because as our technology gets better, as our telescopes advance, we'll be able to see much smaller objects much further away, and who knows what we'll be able to find in our own backyard in our solar system. So give it about 10, 15 years, ooh, I'm sure we'll find some more cool stuff out here. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction right by Pluto. Now, all these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. Whew, 5 hours. Not too bad. But folks, let's leave our planetary scale behind because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Alrighty, so I can see Alpha Centauri just right below us. So we're right in the middle. Alpha Centauri is going to be this one right over here, just down to the left. And again, 4 years at the speed of light for us to get to the next star system closest to us. But that doesn't really put into perspective of how long it would take us humans to travel that. So, folks, if you want to go to Alpha Centauri and you jumped in a space rocket right now, made your way over, it's going to take you about 8,500 years to make that journey. And that's just a one-way trip. Whew. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. And again, we're inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And this first began in the early 1930s with strong radio waves, early television, radar signals, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto the screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We like to call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue because we have spacecrafts where their whole purpose is to find as many exoplanets as possible. In fact, if you look just right behind our radiosphere, we can see that we pointed our space crafts in one direction, our space telescopes, and they found a whole heap of exoplanets in that one direction of the night sky. So if they continue to scan more and more of the night, we'll be finding exoplanets left and right. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so those are on the drawing boards. They got to be constructed and then launched into space, and of course, scientific research. So we got a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system, let's say somewhere on the left hand side of our radiosphere. Let's say this one, we live here. We find an alien civilization somewhere towards the middle. Let's say this one here. We say, hey, we're humans. We live in this area of the sky. We shoot them a text message. Takes 60 years to get to them. They listen in, answer back. Another 60 years to get the reply text message. Folks, that is a 120-year conversation in the making. Whew. And I could barely wait for a text message from my friend. And of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, everybody, we're now looking down at our Milky Way galaxy. This is the galaxy that we live in, and I've got to ask, can anybody see their house from here? Hee hee hee. Just kidding, we're way too far away. And folks, our Milky Way galaxy is really huge. If you wanted to go from one side to the other, it's going to take you about 130,000 years at the speed of light. This thing is big. And the Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If a recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from a sideways perspective. You're going to notice that the Milky Way kind of looks like a big flat pancake or a frisbee. It's really flat. And this is important because, one, when you look up into the night sky, you might be able to see something called the Milky Way. You probably heard someone say, hey, look, you can see the Milky Way up there. What they're referring to is this, that big flat disk. That's what you're seeing up in the night sky. And also, too, this is really important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, nebula, things that block their view of the universe. So again, we like to point our telescopes galactically north and south instead of looking through the plane. So just keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we continue zooming out, our picture constantly is expanding, and we're starting to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other with very few galaxies or no galaxies at all. So we can see a nice galaxy cluster towards the bottom right over here. We can see some on the right-hand side in the middle. We can see very few galaxies on the left-hand side. So you can kind of think of galaxies like people. They like to hang out together, or they like to avoid each other. And folks, we've zoomed so far out now that the picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher and astronomer by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing representation thanks to the work of dozens of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tolley. I love flying through this galactic map. But Now we have automated systems that are mapping even the most distant galaxies. So, folks, we're about to see the very large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And just to let you know, the large scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in the flat spiral disk of the Milky Way galaxy? Well, our Milky Way galaxy would line up right down the middle, up and down, just like so. And again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way. But astronomers still want to make sure that there was galaxies through the plane, so we have this nice purple survey right here. You'll notice that we're still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been filled in yet, so it's just a matter of time. But folks, it looks like we're running drastically low on our tour of the universe. 30 minutes is just not enough, so let's continue pressing on. And now we're going to be encountering these really distant faraway objects known as the quasars. And quasars are short for quasi-stellar radio sources, and they're going to be these orange dots on the left and right-hand side of the large-scale structure of the universe. And these blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the very edge of the observable universe, and what we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't a typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And let's see, this right here looks like a good spot. And let's make our return trip back to planet Earth, y'all. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reach of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of the universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a A good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that the universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that, we made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And of course, we're making our way downtown, walking fast, faces past, and we're homebound. Dun-dun-dun-dun-dun-dun. And it looks like we're now approaching our solar system, our star system, our neighborhood. And now we're about to pass those spacecrafts we sent down in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt, and making our way to the third rock from the sun, our homeworld planet Earth. And all the people that we know, love, ever learned about in history all lived on this one planet, our pale little blue dot Earth. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound. And that's all for today, folks. Thanks for stopping by, and I hope you all get home safe. We'll see you next time.